Mr. Fritz here. In this video we want to solve this trigonometric equation, and we want to solve for angles of theta where theta is between 0 and 2 pi. And let's get started by taking a look first at this equation and see what we can observe. I see a sine of theta and I see a couple of sines of 2 theta, and that's going to make things a little bit interesting. Right now as it stands, they're kind of like unlike terms if you think about it in your algebra days, where this is like almost an x and this is like a y, and we like to have equations that have just x's or just y's. So what I'm going to do is I'm going to actually substitute in my sines of 2 theta for something that has just 1 theta in there. But before we do that, let's combine some like terms together. I'm going to start by actually adding a sine of 2 theta to both sides here. That way I get this thing equal to 0. So I'm going to add sine of 2 theta on the right and add a sine of 2 theta on the left. And that's going to give me 2 sine of theta minus, that's just going to be now 1 sine of 2 theta. And that'll equal 0. Now we have to recall what the identity is for sine of 2 theta. Let me put that over on the side here. The sine of 2 theta is going to equal 2 sine of theta times the cosine of theta. So next up, I'm just going to take this whole piece and I'm going to substitute it in for this piece right here, since those are equal. So next up, that's going to give me 2 sine of theta minus, and then if we substitute in that identity, this should be minus 2 sine theta cosine theta. And that's still all equal to 0. So at this point, yes, I do have a sine of theta and I have a cosine theta, and that might be a little annoying at first glance, but hopefully you can see that I can actually factor out a sine of theta from both of these terms. So let's do that. Let's pull out a sine of theta. And when I factor that out here, I get a 2. Actually, now that I'm looking at it, I can factor out a 2 sine of theta. So let's do that instead. Let's take out 2 sine of theta, and now what I have left is 2 sine of theta. I factor 2 sine of theta out of that, so that becomes a 1, minus, and when I factor out a 2 sine theta here, that'll be cosine of theta, and that's all equal to 0. Okay, so now I have 2 factors that equal 0, so I'm going to split them, and I'm going to set them both equal to 0. So 2 sine of theta can equal 0, or if I solve for cosine of theta here, cosine of theta could equal 1. And these are my 2 equations that are going to produce my values of theta. So really the 2 doesn't matter at all here, because sine of theta will equal 0, since 2 sine of theta equals 0. And I'm just going to rewrite that actually over here. My 2 possibilities are that the sine of theta can equal 0, or the cosine of theta can equal 1. So we kind of have to know our unit circle here, and I'm going to think about where the sine of theta is equal to 0. And sine of theta equals 0 whenever the y is equal to 0, so that's right here and that's right here. So from this expression, or this equation, I get theta can equal 0 or pi. And then I have to think about when cosine of theta equals 1, and that's going to be actually right here once again. So theta could equal 0. So really I've got like a duplicate answer, and so that's going to really, I just have to use the 0 once. Now if this does equal 0 again around a full rotation at 2 pi, but if you think about my original constraints, I am including 0 in my domain but not 2 pi, so we're actually not going to include that in our solution. So overall then, my final solutions here are that theta can equal 0 and pi. And there you have it.